Yes, good morning to everybody. So my name is Emanuele Bonamente, and I'm a postdoc at the Oxford University, working with Professor Bodewitz on cometary science. So I'm gonna show some preliminary results for the analysis of charge exchange emission from comets with NICER. So in the next slide, there is an overview of the instrument. So NICER is the neutron star interior composition explorer, and is an imaging X-ray spectrometer with sensitive to energies in the 0.2 to 12 kiloelectron volt energy range. It is located on board of the ISS, and it was originally designed to study emission from neutron stars, thanks to its very good unprecedented timing resolution. It is characterized by good sensitivity and effective area, and it also has a moderate energy resolution. So when it comes to comet observation, they are observation of such objects is driven by two main characteristics. So comets are moving objects, and usually they are characterized as a faint emission in the X-rays, since they are also observed as extended sources. Because of these two properties, especially background characterization plays a major role in the success of cometary analysis. In particular, the NICER background is characterized by two major contributions, which are produced by the position, which are dependent function of the position of the ISS with respect to the Earth magnetic field and to the solar wind particles themselves, which originate the charge exchange emission. Because of that, we planned the observation strategy requiring a specific observation sequence. So for each pointing on the source, and the source needs to be pointed at different times because it's moving, and the detector needs to repoint it after a few minutes or after a few tenths of minutes. And the sequence is a blank sky observation, then a comet observation, and again a blank sky observation. And we observed that there were systematic differences in the background observation, so the pre-target and the post-target observation at the same position of the sky. And all of our analysis was basically centered in taking into account the proper procedure to extract the background. So in the next slide, we can see that basically our selection procedure produce an event selection for which we only took into account those background and comet observation that took place with the ISS in the similar position with respect to the Earth magnetic field, which means at similar geomagnetic latitudes. And also we applied a selection based on the fact that we would expect in the high energy range of our spectrum, so let's say somewhere above 2 kiloelectron volts, to have a consistent count rate between blank sky observation and comet observation, as we do not expect any charge exchange signal in that region. So after the background subtraction, you can see a preliminary spectrum in the right-hand side plot. We are left with a significant excess at low energy, which is slightly higher than 5 sigmas. We also attempted for a preliminary fit to this spectrum using the VICX2 model and including only carbon, nitrogen, and oxygen ions in the energy range between 0.3 and 0.7 kiloelectron volts. So this fit, again, it's a preliminary results, gives a probability higher than 75% using high solar wind velocity equal to 750 kilometers per second and a plasma temperature of 1 million degrees.
Okay, so 30 seconds.
Oh yeah, sure, almost there. The flux is 2 times 10 to the minus 14 erg square centimeter per second, and it is also consistent to other attempts that we perform to fit the same spectrum with some non-physical models like some thermal Bern-Strahlung emission and a power law. And the goals of the analysis are actually to try to find a reliable strategy for cometary science with NICER, and especially to plan and to analyze future observation. And also to prove that X-ray emission can be used as a probe for space weather condition, and especially at high heliographic latitudes, where usually the space weather is not monitored continuously. And further developments of this analysis will include the improvement of our background estimate. So we still are working on refining the cuts that we applied, and also new instrument response function have just been released. And also we will test the fitting model against alternative hypotheses. And we are finally waiting for to start observation of comet 88P Howell in September 2020, which will be observed in close to the sun equator plane, so likely in a very slow space weather condition.